Hey, good morning. This is Faiz Sayed. So today is my final project assignment. So today I'm going to give you the presentation about the comparative study of operating system. Welcome to my presentation on comparative study of operating system. This presentation examines major operating systems covered through the course and compare their architecture, usability, security, hardware compatibility, resource management, and practical application. This course examines operative system structure, file system, memory and management, processes, resource management, and distributed system, and security. I will focus particularly on Windows, Mac OS, Linux, Chrome OS, and Android and iOS. Rather than simple describing these platforms individually, this is the presentation considering their strength, limitations, and ideal application. Understanding this difference helps organizations and users select platforms appropriate for their technical and operational requirements. Understanding operating act as an intermediary between hardware applications and user. It responsibilities include CPU scheduling, memory allocations, file management, device management, security, and input-output operations. The course especially require outstanding process management, process scheduling, currency, concurrency, deadlocks, synchronization, memory management, file management, and disk scheduling. This responsibility may appear similar across platforms, but operating systems implement them differently. Windows Enterprises Desktop Standards. Windows remains highly important in the business and personal computing because of its extensive application ecosystem and broad hardware compatibility. Its familiar interface can reduce the training requirement, while enterprise technology support centralized in the administration. The course specially cover Windows troubleshooting and Windows 11, and Windows provide important security mechanism, but its whispered deployment also makes security management particularly important. Linux differs. Linux flexible open source computing. Linux differs considerable from Windows because it is open source and available through numerous distributions. This flexibility allows user organization to customize operating environment for several servers, desktops, embedded system, dot platform, and a special application. This of course include Linux desktop computing as one of its comparative platform. Linux also extensive and command line administration capabilities make it particularly attractive to system administration and developers. Mac OS integrated Apple computing. Mac OS provide an interesting comparison because Apple develop operating systems alongside the hardware and on which it runs. The course explicitly compare Apple Mac OS with Linux desktop environment. Tight hardware and software integrations enable Apple to optimize performance and create consistency user experience. Mac also has a unique Unix Foundation provides useful command line and development capabilities beneath its graphical interface, a controlled ecosystem. Chrome OS Cloud in centered computing. Chrome OS presents a different operating system philosophy because it's developed primarily in browser and cloud-based computing. The syllabus includes Chromebook and Chrome OS alongside network connectivity rather than emphasizing larger locally installed applications. Chrome OS encourages user delay on web applications and cloud storage. Its simplified architecture and automatic updating can reduce administrative complexity, particularly education and other environment managing many devices. Sandboxing can isolate application and browser process, providing security advantage. However, cloud dependence can become a limitation where network connectivity is unreliable and specialized desktop software is required. Mobile system Android versus iOS. Mobile operating system can face challenges that differ from desktop platforms. The course specially examine iOS and Android. Smartphones must balance performance with a limited battery capacity, wireless connectivity, privacy, security, and touchscreen usability. Android provides a more open ecosystem spanning many manufacturers and price uh, categories, and while iOS operates within Apple tightly controlled hardware environment, applications, sandboxing, and permission systems are important security mechanism on both platforms. Research by Enk L. 2014 demonstrated the value of systematic analysis of Android. Process scheduling and resourcing management. Process management is one of the most fundamental operating system responsibility and a major course learning outcome. Multiple program may appear to run simultaneously, but the operating system must determine how process resources are distributed. Scheduling algorithms attempt to balance objectives including responsiveness and fairness throughout throughput and resource utilization. Thread allow applications to perform multiple activities currently, while synchronization mechanism prevent unsafe access to the shared resource deadlock occur. One process become unable to continue because each is waiting for resource held by another. So memory and storage management. Memory and storage management demonstrate how operating systems balance performance against limited physical source. The course include evaluating trade-off among main memory, cache memory, uh, memory, and process speed. Virtual memory allow application to operate with a address space that exceed immediately available physical memory. Storage system must meanwhile organize persistent data efficiency and reliable. Different operating system employ different file system and technology and coaching strategies. Explain next. Security across the operating system. Security is another major responsibility of an operating system and one of the course stated learning outcome. The students are expected to articulate why protection and security are necessary within operating system. Uh, Windows, Mac OS, Linux, Android, iOS, and Chrome OS use different combination of authentication, performance encryption, sandboxing, and software update. No operating system is automatically secure under every condition because security also depend on configuration and user behavior. Visualization changes operating systems development. Visualization has transformed the relationship between the operating systems and physical hardware. Desktop visualization is especially include the course curriculum. Hyperversion allow multiple mechanics to machines to share an physical computer while maintaining logical separation. Organization use virtualization for severe consolidation development, testing, disaster recovery, and cloud infrastructure. Snapshot also enable administrator to preserve system state and restore environment efficiently. Barham et al. 2023 demonstrated that significant of action and virtualization of efficiently supporting multiple operating environment on the modern and computing extend this principle across large data center, making visualization. Network and cloud file management. Modern operating system cannot be evaluated independent from the networking and cloud computing. This syllabus combines desktop and laptop network connectivity to the cloud file management operating system, provide network stock, interface management, remote access, capabilities, firewall control, and cloud organization. Cloud storage has also changed traditional assumptions about their user user files reside information may be synchronized among laptops, smartphone, tablets, and remote data center. This increase convenience but create additional privacy, authentication, availability concern. Comparative operating system overview. When comparing this operating system, this is a universal winner because its suitability depends on the requirement. Windows offers extensive commercial software compatibility and enterprise management capabilities. Linux provide customization and strong server and cloud capabilities. macOS benefit from hardware software integration and consistent user experience. Chrome OS emphasizes simplicity and cloud-based operations. Android offer enormous device diversity, while iOS provide tight integration within Apple's ecosystem. Future operating system trends. Operating system will continue evolving. Computing become more distributed, intelligent, and cloud connect. Artificial intelligence may increase assist with the performance and optimization, detect troubleshooting, and resource allocations could. Cloud computing will continue blurring boundaries between local operating system and remote infrastructure. Containers provide a lightweight application isolation and portability, while edge computing require operating environment capability of functioning across decentralized devices. Conclusion. The comparative study demonstrates that operating systems are much more than interface for launching applications. They manage processors, memory, storage devices, network applications, and security while providing environment which users can work productively throughout the course. The studying Windows, Linux, Mac OS, Chrome OS, Android, and iOS provide a broader understanding of how different design decisions address different computing needs. The syllabus emphasizes both understanding internal operating system structure and evaluating trade-offs among resource and security requirements. Personally, this knowledge is valuable of system administration, cybersecurity, cloud computing, troubleshooting, networking, software development, and IT infrastructure planning. Thank you. And these are the references which we have taken from.